Hey everyone, welcome to the DigitSQUAD AMA, which is all about testing smartphone cameras. That's what today's session is all about. So, that's basically what we're looking at. This is about testing smartphone cameras, and the idea is to basically help you understand how we do it so that you can do it as well, and essentially evaluate your smartphone camera, submit a review within the first week, within the next 1 week, and we'll pick out the best one and then take things from there. Okay, so this is essentially a part of the DigitSQUAD certification program. And if you guys were here with us last week, we did a session on benchmarking your smartphone. So the idea was to help you guys understand how to benchmark every aspect of your smartphone's performance metrics. So that's GPU, CPU, display, battery. All of these components sort of have to play together in order to help you get the best from your smartphone. And one aspect that was left out from that session was camera, because camera testing is a whole different beast altogether. We've now got smartphones which have large format sensors, small sensors, multiple camera systems, multiple different aperture values. They can do so many things. So the idea is that today we're going to dedicate basically to just how do you test a smartphone camera. So just to give you a rundown of things, this is how you so this is your opportunity to be a digit certified smartphone reviewer. So this is the second workshop in the program for smart, and it's called the smartphone camera testing workshop. So this is part of the Digit Certified Smartphone Reviewer program, and at the end of completion of this program, you get a reviewer certificate. So that's pretty nice. And the idea is to help you become a more credible influencer within your own community. And Digit Test Lab has been there for over 10 years, so that we want to share all of our expertise with you so that you also grow as our community grows, and then you will go out further and help other people learn as well. So this is an opportunity. There are a lot of opportunities that will come after this. So if you do get the if you do become a digit certified smartphone reviewer, you can get invited to Digit's office to basically test the newest and the latest gadgets with us. And of course there's also the opportunity to intern with us, which means you come in, you work with us throughout your duration, which would be anything between 1 month, 2 months, 3 months. We can decide that later, but you get to work with us. You sit and you see how we run our test lab, how we test not just smartphones but other devices as well. So it's a great opportunity. So of course, this session is going to be divided into two parts. I'm first going to go through my presentation, and of course there will be a Q&A session which will come after the presentation. It'd be great if you could save all your questions for last. That's the best way to go about it. And if you do have those questions and there's something specific to a slide, we can always go back to the slide and revisit whatever it is that you may be curious about. I do hope you'll have as many questions as possible, because today the smartphone camera is single-handedly taken over the camera industry. Like, it's pretty much destroyed the entire share of point and shoot cameras. People are no longer buying DSLRs because the smartphone offers a decent enough experience. So we're going to look at some of the myths that are surrounding smartphone cameras, some realities. We'll be going over how you test them, and we'll make it easy enough for everybody to follow. So we're just gonna quickly wait for another 5 minutes, and we'll kick off the session in that time. Hi Aniket, how's it going? You're the first one here. Thanks for joining us. Hey, tech for YouTubers. Hi, how's it going? Doing great, awesome. While we wait for other people to join us, why don't you guys tell me what phones are you all using right now? Hi, Ashu. I'm really glad you guys are here as well. It's really nice, because there's nothing better than sharing everything that we've learned. And the idea is that the squad was always, Digit is in fact always been about its community, about its fans. And there's nothing that's more fruitful than, helping you guys also learn and understand the way we do things, so that you can go out, because at the end of the day not everybody has access to the Digit website, and not everybody may understand what we write and how we write it. So you guys are like our best way of getting that message out, so we want you also to know and learn how we do things. So now that we've got a bunch of people who've come in, so I'm just going to quickly recap. This DigitSQUAD AMA session on smartphone camera testing is part of the Digit Certified Smartphone Reviewer program. The idea is that we've already hosted one workshop which was on benchmarking smartphone performance. This is the second one, which is smartphone camera testing, and after this you will have a week to basically take everything that you've learned from these two sessions, apply it to your own smartphones, write a review, and submit it to us. And when we go through them, we'll decide which one of those reviews was the best. And after that, there will be a certificate given out to those who meet the criteria for being a Digit certified smartphone reviewer. And after that, there's also the opportunity to come in and intern with us. So that's pretty awesome. And you guys will basically get to have access to all of the latest smartphones, all of the latest devices, some of them even before they come out. So that's bragging rights right there. So excuse me. So with that being said, let's kick off this session. Before I go into my presentation, I'm going to request you guys to save all of your questions to the end, and because when I start presenting, my screen gets covered up and I cannot see the YouTube chat. So but I will revisit all of them. Every question of yours will be answered in today's session. I'm here for you guys, so don't worry about that. Before I get into the presentations, I already have a question. Which microphone am I using right now? So this is one of my I think this is a Logitech G series gaming headset. That's what I'm using right now. I'm not exactly sure what specific model, but I just know it's a Logitech G series headset. Alright, so that being said, let's get into smartphone testing. There we go. So we've got smartphone testing. It's okay, it can be actually very tricky to test your smartphone camera, because a camera essentially relies on light, right? And even if you shoot the same scene twice, you could get slightly different results, because between taking the two shots, maybe your camera moved a little, maybe clouds came in, light changes, so all of that happens. And that is why we've kind of designed this smartphone testing process to have some very specific shots. I'm going to walk you through what are some of the image parameters that you should look out for, what we look out for, how to test for them, and how to analyze them. So on that note, let's get started. So here are some of the most important image characteristics that you need to look for. There is something called dynamic range. You have sharpness. Now the image has two areas of sharpness. One is the center and the other one are the four edges, the four corners. So the reason why you look at the corners as well is because all they're all sort of spherical in design, right? So sometimes what happens is that the sharpness is greatly reduced towards the corner. Now that is a sign of a badly crafted lens. So typically, to be honest, when you're shooting with ultra wide lenses, you will see some distortion, you will see a drop in sharpness, and that is normal. But if you ever using a wide angle or like a regular wide lens or a telephoto lens and you see soft corners, there's a problem there. After that, there is also contrast. Now sharpness and contrast sort of work hand in hand. Reason being, there's something called local contrast, which basically determines the difference in shade between two pixels. So let's say if you shoot a scene and it's a leaf, right? The difference between the textures of green is basically denoted by local contrast, and because you're able to see that separation between two shades of green, you say, oh, this image is sharp, so it's actually perceived as sharpness, which is why these two things go hand in hand. We also have something called detail retention. Detail retention essentially refers to things like texture of the skin, or let's say the fur, the hair on a furry dog. I mean, I have a dog, so he'll show up quite a bit in my presentations and my camera samples. The reason we do this is because when you take a photo, let's say of a human being, you don't want their skin to look like flat plastic, one shade of brown or one shade of pink, whatever, right? So that detail, the rich detail of the textures of the human skin, are sort of what make that photo of the person very, very interesting. So detail retention is very important. Why this detail retention thing takes a hit is because when you take a photo, that raw data coming from the sensor passes into the ISP, and then depending on how the camera manufacturer or the smartphone manufacturer has programmed that ISP to behave, that raw data is converted to JPEG. And when that happens, a lot of compression happens. The data that is not used in the JPEG image, so raw data is like that much, and then JPEG data is that much, everything else is discarded, right? So in order to reduce file sizes, a lot of manufacturers will apply heavy compression, and that sort of can take a hit in details. So we've got that. Then we have color reproduction. You don't want to take a photo of a friend and have their skin appear orange, right? Or you don't want to take the photo of a beautiful sunset, which is this gorgeous orange and blue hues, and have it all look pink, right? So that color reproduction is very important. It's affected by the camera's ability to white balance, and of course also the tuning. The last two characteristics are noise. The noise usually appears in situations when you're shooting in low light, and if you've got very, very strong shadows even in a well lit scene. So there is that. And last but not the least is distortion. Again, distortion happens when have you ever tried to take a photo of a person and gotten really close to their face and everything just sort of stretches out? That's distortion. That is normal, but you should not see distortion on a 24 mm lens in that pronounced way, and definitely not on a telephoto lens. So we've got that. Let's just now switch to dynamic range. So there are three components of dynamic range. It's one of the most talked about things in camera testing, and it's important to know what dynamic range actually means. There are three components. There's highlights. Highlights are the areas of your image which are directly lit by the source of light, and these are the brightest looking parts of your image typically. Then you have midtones. These are parts of the image which are indirectly lit but are still bright, okay? And then you of course have shadows, which are basically areas that sit in, they're not getting light, so they're in the shadow. And a good example would be this particular image right here. So if you look at this scene, you have all three, and you have this one main building which is being lit by the sun, so that's in the highlight area. The midtones would be this glass ceiling sort of a thing that I've marked in with arrow, because it's actually not directly lit by the sun, but it's indirectly lit, it's still bright. And then of course the shadow part would be these little plants. It should have been vibrant green, but it's actually turning to black, so that's the shadow area. A good camera sensor should be able to produce this image like you see it. You would know that your image sensor is sort of not that great if the shadow area, for example, starts to show noise. And how you assess that, how to figure out if you have noise or not, we'll discuss in one of the later slides. So let's talk about how we actually go about testing the image quality of a camera. So we use something called the ISO 12233 chart. It's actually, we're going to break up this testing process into two parts. One is of course there are actual scientifically designed charts that are there to test specific parts and specific aspects of image quality, the image quality parameters that we talked about earlier. And so we're going to go over the chart side of it first, then we're going to go about how to actually also use real world images to make the similar assessments. The advantage of using a chart is, one, it's the exact same subject. Two, if you have these charts set up, you can control the lighting, which is extremely critical. You can control all of your shooting conditions, therefore making sure that between, let's say, 2, 3, 4 or even 50 smartphones that you test, your image data is consistent. The problem with doing real world assessment is that on a day-to-day basis, various things change. The amount of illumination changes, maybe the subject that you're shooting changes. If one day you may be testing with there's a lot of pollution, or maybe there's a lot of fog in case of winters, and then the next day the sky is completely clear and everything is clean. So the image quality parameters change based on the ambient world. Therefore, the charts are a very, very good way to sort of collect image data. Where you can get these charts, I'll cover that in a later slide. My light source just died. Oh, there we go. Where we can get these charts and which ones to use, we'll go over that in a in the Q&A. We can go over it. So the first chart is the ISO 12233 chart, and this is sort of what it looks like. Now this chart, it's broken down into multiple. This is helping us test multiple aspects of your image quality. The first is resolution. How much detail can a sensor and lens combination resolve? If you notice, you have these markers on this which say 4:3, 3:2. So the idea is that smartphone cameras have an aspect ratio of 4:3. So when you're lining up your camera to shoot this particular chart, these are your border guidelines. So your frame should basically cover this 4:3 mark. That's one. If you're using, and the best part is you can also use the same chart to test a DSLR camera or a point and shoot camera. So that's why you have the 3:2 marker, which you can use to line up a camera which has a 3:2 aspect ratio image output. Studying this chart, let's go over the various parts of it. So this center is this square with a circle inside. This is helping us study the two aspects. One is center sharpness. If the lens is not sharp enough in the center, you will not be able to see any separation between the fine lines over here. Very fine lines, and you won't be able to see them. Similarly, this is surrounded by these four arching lines, which, well, you could use a software to draw this assessment, but if you want to just eyeball it, the easiest way to do it is there are number markings on here, and you can use that to sort of assess how far can the sensor resolve details. So if, for example, over here in this little part it says 20 and you have a 20 megapixel sensor, you should be able to see the separation between lines over here as well. So you have this across the frame, and the idea is that this chart helps you study the sensor resolution reproduction, detail reproduction across the sides, which is the corners, the top, the bottom, the right and the left. Also, it allows you to assess the corner sharpness and the center sharpness. So this one photo is essentially helping you do two things at the same time, and that's actually very, very helpful. Second thing which is very important to look at, the second chart that we use is very simple. This is simply a checkerboard pattern. We use a we use a white and gray checker box. You could also just have grid lines, just make sure they're not too thin. And what this will do is, when you place your smartphone camera at a specific distance from this chart, you will be able to tell how much distortion that lens presents, because, well, these are straight lines, right? So if you go too close, you will start to see these lines bulge outwards. That's called barrel distortion. And sometimes what happens with telephoto lenses is that they're designed to compensate for that distortion, right? So you get something called pin cushion distortion, where it starts to pinch towards the center. So having a grid pattern is very, very helpful in sort of assessing the distortion aspect of it. Now, I want to talk about the fact that ultra wide lenses on smartphone cameras will always result in distortion. It's a given. That's the very nature of ultra wide lenses. So the idea is that if you set a specific distance from the chart, you can measure the degree of distortion for all types of lenses, whether it's ultra wide, whether it's wide angle, or 2x, 3x, 5x, 10x telephoto lenses. Of course, you'll need to have that much distance. Ideally, if you're going to use a chart like this, sorry, it's 1 second. So ideally, if you're going to use a chart like this, print it out in about 5 feet by 5 feet size. Unfortunately, this chart does require a lot of space, but there is a workaround. So we'll cover that in the real world testing part. Okay. Then we have color reproduction. So color reproduction is very, very important, and let me just quickly talk about that with you guys over here. The image got missed. Let me just add that quickly. This happens sometimes. There we go. Okay. Right. So this particular chart, so this particular chart is basically helping you assess the image quality with regards to color reproduction and the grayscale, so white balance essentially, and of course the color reproduction. So on top you have these 24 color squares. There's also a hardware you can actually buy. So this is printed, but you can get something called the X-Rite color checker, which is this exact same thing. 24 color boxes. They're printed using a very specifically calibrated ink, so you know the exact specific shade you're gonna get. When you take a photo of that, you then figure out exactly how much color shift you're getting. The color shift is actually, you can calculate based on the little boxes at the bottom which go from white to black, and they help you figure out. So if, let's say, this white box over here, this is supposed to be pure white, is slightly going towards yellow, right? So you'll start to see a shift in all of these colors here. So this is going to help you assess what level of colors you can expect from your camera. Now when you're shooting something like this, my recommendation is take multiple samples in all sorts of lighting conditions. That's just very helpful. Then let's now move over to the real world testing and sample and representatives. This is very, very important. Real world representative samples do two things. Now the charts that I showed you, if we were to put those out in our reviews, it'll be so technical, a lot of people would not understand. Plus when you upload charts to the web, you have to resize them, there's compression involved, there's all sorts of things involved, and that sort of takes away from the quality, right? So, and plus people relate more to real world scenarios. So I've got a few real world samples over here that specifically look at the parameters we've just discussed. Now this is fine to use for testing cameras as an estimation. Charts are definitely the most reliable way to go, but as you become more and more experienced, you will be able to draw inferences using real world samples as well. But there are rules to that, so we're going to talk about that. The first one, let's say dynamic range, usually shot during the daytime, of course, because that's when you have the camera going through its most difficult situation of trying to resolve detail and resolution and dynamic range. So in this photo, for example, you have the sun in the frame, you've got parts of it that are backlit, you've got parts that are directly lit. So this is going to be a good assessment. The other thing is shooting stuff like this which is against the sky. Typically a lot of things in the foreground will be in a shadow area, or at best mid-tones. So you, as you can see, the tree over here, for example, is completely in shadow, whereas this building over here is in the mid-tones, and you have the sky which is completely in highlights. Important thing about dynamic range is what you see is that the clouds, for example, in this image are not completely blown out to white. That's very important. That's where you know that okay, detail in the highlights are being retained, my highlights are being retained. And where you do see the image suffer a little bit in terms of dynamic range is in the shadow, because there are parts of the street that are completely black and there's no detail there, you can't see the green. So this is sort of how you look at dynamic range in the real world. Make sure that when you shoot, you frame it in such a way that you have all of these three things in the frame. You can't just have one or two. Midtones will always be there, that's just a factor of light, but you have to make sure that there are strong areas of shadow and strong areas of highlight, and balance that out with the midtones so that you know for a fact that you have all three in your frame, and you can make your assessment based on that. Detail retention is one of my favorite things to test because it involves a lot of food for me. The food we eat has a lot of color, a lot of texture, and it's so rich in detail, whether it's something that's liquid or solid or semi-solid, whatever it may be. And this is sort of where you're looking for detail. When you're shooting a photo, in order to assess the detail, you have to make sure that your hand is very steady, there's no shake involved, because typically what tends to happen, even the minutest of shakes will eventually cause some level of distortion or some level of blurring in the photo. And then you may think, oh, maybe this camera is not that great, but that's not the case. One really important thing to keep in mind when assessing detail is 100% crops. So the image on the left over here is, this image is the original, and then this is 100% crop, which basically means that you view a portion of the image at 100% zoom in, and you get to see exactly how much detail there is. Like, there is every fiber and every strand of my dog's fur is distinctly visible. And yes, this photo was actually shot on a smartphone, not on a DSLR. There is this level, and this is the only way you can actually tell whether the detail retention is impressive or not. Because if you don't look at 100% crop, you'll never know exactly how much detail the camera is retaining, because when it takes this 12, 16, 20, 48, 64 megapixel image and packs it into that 5 to 6 inch display, everything will look tack sharp, everything will look very nice. But it's only when you blow it up that you start to see the real nature of things. Now let's talk about distortion. So I told you guys about that chart, and it takes a lot of area, can be very difficult to manage in a lot of houses. So the best way is find yourself a flat wall, preferably like a brick wall or something which has lines. And like I use this wall outside my house which has multiple doors, and this acts actually as a really good indicator of the level of distortion on a smartphone, because you'll start to see the bulging of straight lines every time you're shooting with a lens which has bad distortion, or you'll start to see pincushion distortion based on if there is pinching due to a telephoto lens. So that's the parameters. And I know you guys must be wondering, but what about low light testing? Literally repeat everything that I just talked about in a low light situation. Now this is where the tricky thing happens. This is why charts are important. When you're using a scientifically created chart, the ones you saw in my in the presentation prior to the slide, you can actually shoot them in good light. You set up lights in your room. I'm sure most of you have LED lights or bulbs in your room, and just start to lower the brightness of ambient light, and then you'll be able to control exactly, you'll be able to basically assess all of the previous image parameters across the ISO range, and going from brightly lit all the way down to poorly lit. Now this applies to color. In low light you will definitely see some color shifting, because as the sensor starts to boost its ISO, as it starts to become more sensitive, it also starts to mess up on white balance, and it starts to see colors slightly differently. So it's sort of like that. So when you're doing your testing, very very important to sort of keep some things in mind. Always use a tripod, and when I say always, I mean in good light outdoors. If you're shooting something very wide, then that's fine, but typically if you're shooting anything indoors, you're doing some light control testing, always use a tripod. It helps eliminate not just handshake, but it also makes sure that your frame is consistent, like literally between pushing the shutter button and the frame being captured. If your hand shakes, your test sample is gone bad. So a tripod is very important. Second is control your lighting. Now I started this session by saying that charts are important, because as light changes throughout the day, the characteristic of the world around us changes throughout the day. So this is very very important, like control your lighting. So ideally, if you can create even a test scene. Now here's the best part: all of the things that we talked about in the scientifically calibrated charts, everything, you could recreate that in a small test scene within your own room, and you could light it up using budget friendly LED lights. As long as you maintain the color temperature and you maintain the same brightness, you're good to go. And when you control the lighting, you can simulate for good light, poor light, low light, a bright daylight. And one thing to keep in mind, if you're simulating low light photos, make sure to change the white balance to a more cooler side. That's one thing that a lot of us don't realize, is that at night times typically the eyes are seeing a much cooler white balance as against the daytime. Then there's of course review your images on a computer. Ideally, always on a computer, so you can blow images up to 100% and see them in greater detail. If you can use an IPS monitor, which tends to be more color accurate than any other monitor in the market out there, that'll always be a great great at helping you assess images. There's of course studying your images at 100%. That's very very important. And always shoot in multiples. So when I say that, I mean two things. One is of course use burst mode, so that in case there is any handshake, there is at least one frame that is tack sharp. Second thing is, if you're shooting, let's say, to assess dynamic range, one image will never be representative. You will have to shoot multiple samples. Same thing with low light, same thing with trying to capture detail information. All of that, you have to shoot multiple samples of the same for the same parameter that you're testing. That's one. Second thing is, the one aspect that you can avoid multiples of is when you're trying to study distortion and vignetting. So that's totally up to you. So that's it for my presentation, and now I would like to open the floor up for Q&A and discussion and whatever you guys may want to know about. So yes, that is a quick recap and a quick look at how we do smartphone camera testing. These same tests are also applied to every camera module, so you can do this with the wide angle lens, you can do this with the ultra wide, the telephoto, all of that. So yes, let's go ahead and do the Q&A now. Okay, Sudeep Saha, you want to know if image is distortion due to unsteady hands, can image stabilization improve it? Unsteady hands don't produce distorted images, they produce images that are slightly blurred. Yes, OIS can help, but when I mean distortion, I mean things becoming more round than they should. So yes, OIS will definitely help in preventing shots that get blurred because of handshake. Okay, then let's see, how far do we have to paste this chart from our location? So I'm assuming, Arpit, you're talking about the ISO 12233 chart. It's not about how far it is, it'll actually depend on the focal length of the camera. So what we do is, we have the chart on a wall, and that chart doesn't move. What moves is our camera that we're testing. So if it's an ultra wide lens, and of course you have to go closer, because the idea is your frame should be bound within that 4:3 aspect ratios. Let me just pull that chart up again. This is the chart, right? So you have to move the camera close so that you're actually filling up. Your frame is only this fitting in this 4:3 area, and you're not shooting anything outside of it. That's very important. So yes, your camera will have to move, and the distance will basically depend on what is the focal length of the camera that you're shooting with. If it's ultra wide, then you'll have to get very close. If it's telephoto, then you'll have to step back quite a bit. So there is that. Okay. Kedar Nayak, what about shutter speed? Can you elaborate on that? Like, what do you mean about what about shutter speed? I would love to take this out. Okay. Okay. Tips while using shutter speed. Okay, if your shutter speed is slow, again, tripod mounting your smartphone will really help. If it has OIS, that will also help. But there is a very simple rule to shooting with OIS. Optical image stabilization is only effective if your shutter speed is 1 over focal length. Little bit of math there. I love math. So let's say if you're shooting with your regular wide angle lens, which is a 24mm lens, right? Your shutter speed, if it goes below 1 by 120, so if it goes below 1 over 24th of a second, 1/20th of a second, even with OIS, you can still get camera shake. So always keep a shutter speed that's faster. Shutter speed, of course, you can only control if you're shooting in pro mode, and honestly, I would much rather have you guys have a slower shutter speed than boosting ISO. This is where a tripod comes in, and if you don't have a tripod, let's say if you're in a hotel, if you're in a restaurant or a bar or a club, whatever, and you can't whip out a tripod, you can always hold the smartphone in a way that you have 3 points of stability, so you can lean up against something and then stabilize the camera. So okay, does megapixel really matter, or is it just marketing gimmick? Because nowadays we have 108 MP camera smartphones. Sagar. Okay, Sagar, the answer to that question is they do and they don't, but I'm going to break it down for you in the context of testing. You will know whether a certain megapixel number on a specific camera matters or not only when you shoot, let's say, this particular chart, and you say, okay, I have a 108 megapixel sensor, but I'm not able to see detail past the 18 mark on these charts. That's not good, that's bad. Or if you're not able to see detail in the center circle over here, that's not good. So the idea of a higher megapixel was always to resolve better detail, but not all of them will do that. Now the problem is, with the megapixel amount becoming bigger and bigger, the sensor size is still the same. We're still playing with about half-inch size sensors, it's 1/2 or 1/2.3. We're still playing in that rough range. So what happens is, manufacturers are giving a higher megapixel count just so they can bin the result and create a better image. So when you guys test, I would very strongly advise that you shoot in the native resolution. If it's a 48 MP camera you're testing, shoot in the 48 MP mode and then shoot the same image in the 16 MP mode. We do this and we're able to tell the difference, and that difference shows not only in terms of the dynamic range, but also in contrast, also in color reproduction, and also in detail retention, also in sharpness. Like, it's crazy, but it is there. Okay. Ashu Mishra, what is the rule of thirds in photography? Oh boy. Okay. The rule of thirds in photography states that when you look through your camera and you see your frame, draw a 3x3 grid and frame your subject at the intersection of any of these lines, so where your grid intersects, because apparently that's where the human visual cortex tends to draw attention. So there is a concept of negative space where you can have your frame is only having a subject in the right or the left 1/3, and everything else is empty. So if you notice a lot of landscape shots with mountains and sky and things like that, or just any kind of landscape shot, you will tend to notice that the bottom 1/3 has the landscape, whereas the top 2/3 will have the sky. So find your favorite images and just draw a 3 by 3 grid on it, and you'll know what the rule of thirds is. Also, as always, some rules are meant to be bent, some meant to be broken, and there are a lot of photographers out there who violated the rule of thirds and produced some beautiful images. So it's a guideline, I wouldn't call it a rule or a law. Okay. Eklavyan. Most brands give quad camera nowadays, but Google optimizes the Pixel device using Google Camera API. So what decides camera quality? Is it just optimized software or hardware matters? They both matter. You can't have poor quality hardware and expect software to work magic. I don't know if you guys know this, but like in the early days of computer programming, like when I was in school, one of the first things we were taught was garbage in, garbage out. At the end of the day, if you're putting garbage data into your ISP, there's only so much it can produce, right? And a good example would be if you're trying to take a photo in pitch dark. Good luck trying to produce a perfectly lit, beautiful, detailed, rich image without having like a 5-minute exposure. So there are all these parameters, right? Yes, software also matters, because believe it or not, the data coming out of the camera sensor has very little color information, very little sharpness, very little contrast, and but the beauty is that it contains so much information that all of this can be added back in without destroying the image. So if you have a smartphone that is capable of shooting raw images, I very strongly suggest that you take a photo of something that's very colorful during the day and shoot it in raw and JPEG, and you'll see the difference. So software and hardware both matter. Companies like Google, like Huawei, Apple, they work on both. They're very, very tightly controlled on the hardware aspect of it, which is the sensor and the lens. Lenses, guys, believe it or not, they make or break your photography rules, because here's the thing: lenses also have a resolving power. If you have a 64 megapixel sensor that's been paired with a lens that can't resolve 64 megapixel worth of resolution, then you're always going to find problems in the images that come out of it. And we've actually got an interesting article coming up on this. It's a discovery made by Shubhrojit, who took the previous session on benchmark testing. He and I have been talking about it, and we've got an interesting article coming up about lens resolution, sensor resolution, and binning, all of these things. Rush premium. Today there's been an issue with close-up shots with bigger sensors to completely focus the subject. Is there a way to avoid that? Rush premium. Every lens has a minimum focusing distance, so there is only so close you can get, and because of that, sometimes if you get too close, then you will not be able to get the subject in focus. So the best way to figure out what is the minimum focusing distance is, if your smartphone has a pro mode, go into pro mode, switch off autofocus and go to manual focusing, and then turn the dial all the way to close. You'll be able to then tell exactly how close you can get to the subject without losing focus on them. Ashu Mishra, why there is a difference between the Google camera versus normal camera application provided by companies? This is because a lot of the processing is determined by the camera apps, and Google builds its algos into its own camera app. And there's, of course, on Pixel phones you also have the Pixel Visual Core, which is designed to help other applications leverage the same algos and whatnot. But the camera application itself also carries this the rules by which these images should be processed, which is the reason why. So if you sideload the Google camera app on your smartphone, you will see you can actually go into settings and tweak a lot of the parameters in terms of curves, color, saturation, sharpness, how many frames do you want to take for every HDR shot, things like that. Okay, Rishi Kumar wants to know what is aperture and what's the difference between variable apertures. What aperture is good, lower or higher? Buddy, that's a very good question. So if you look at your smartphone camera, you will see that inside the lens you will see a little opening. That opening is called the aperture. That is the hole through which light light goes in and is essentially focused and tunneled onto the sensor. On a DSLR lens or on a professional lens, you can change the value of this aperture because that's how they're designed. But on a smartphone, that's not possible because apertures tend to be they have to be very very thin, and therefore they are very delicate. Samsung managed to create a dual aperture system, but it's mostly a two curtain system. On a DSLR, your aperture blades are made out of maybe 9 or 10 components, 8 components, so that they produce a perfectly rounded circle. But on smartphones, that's very very difficult to achieve. What is a good aperture is very tricky to answer, simply because if you have a very big aperture, that means it's going to let in a lot of light, but that also comes at the cost of sharpness. If you have a very very small aperture, you will have a sharper image, but then the light going in is less. So if you'll have, basically, let's say, with a big aperture, it's great for low light, but with a small aperture you cannot shoot in low light. So there is that. Okay, Kedar Nayak, most budget phones don't give the option of using camera manually. Any manual camera software you would recommend? Okay, excuse me. There are quite a few apps that you can use to take photos, third party, but it really will depend on whether they have the camera to API enabled or not. If they don't, then third party apps will also not be able to give you manual control. So you can look at anything like Snapseed. You can look at I personally use Lightroom Mobile to also take photos and edit them, so those are good options. Okay. Okay, Arpit wants to know what is the difference between optical image stabilization and electronic image stabilization. On which stabilizations we have to consider the most? Oh, interesting. I love this one. OIS is considered superior to EIS. So reason being, optical image stabilization works by basically moving the lens elements up and down in such a way that the image that is being cast on the sensor does not move. So that's basically how OIS works. What EIS does is, so let's say if your camera sensor is it's a 12 megapixel, but if it offers you EIS, there's a very good possibility that it's not 12 but maybe 12.4 or 12.6, maybe even 13 megapixel. The extra resolution, basically what happens is, with EIS the image is digitally altered in such a way that the extra resolution goes away and you get a 12 megapixel image with the subject being completely in focus and like no shake being there. So there is that. In terms of which is better, OIS is definitely a better bet because it doesn't end up costing you resolution. It works reliably, but with EIS, the great thing is that EIS is cheaper to implement and it's easier to implement because it's software based. What's really best is a combination of the two, and that is pulled off by very few people. Okay. Rakesh Rao, yes, Gcam can produce RAW in smartphones, but of course you'll have to like figure out if there's a Gcam variant available for your smartphone. There's a bunch of things to consider. How much reliable is DxO mark testing? Because some of smartphones with low scope performed excellent in real life photo shoot. Sagar, oh boy, you have brought up a very very good question. You see the charts that we just talked about, right? They're very similar to what DxO is using. Now these are scientifically created charts that study very specific parameters of a camera. DxO, what they do is they take these tests and they either improve them, customize them based on what the modern day scenario is. For example, some of these charts may not work with a 108 megapixel sensor. There is an update that is needed to be added to the chart so that they can look at resolutions as high as 108. But DxO is really on on top of it. What they also do is that they create their own custom tests based on their research about, let's say if people are starting to shoot a lot more in low light situations. Excuse me. So they'll have they'll create a very specific set of low light tests. So they basically build their brand on the fact that they have a lot of scenarios for testing. What they then do is they go to camera manufacturers, and in the early days it used to be DSLR manufacturers, point and shoot manufacturers, or even lens makers, and say, here, buy our tests, use it to assess your devices before you release them, and we guarantee that you will have a very good performing device. So that's what happened. Now a lot of smartphone companies do this. Most of them don't disclose it, which is totally fine. And the reason DxO ratings should be taken with a pinch of salt is that it's kind of like having the question paper before you take the test. Because if I have the DxO lab set up in my camera manufacturing factory, and I've calibrated my smartphone camera using DxO's test, when my smartphone goes to DxO for testing, I can expect to score well. But the really cool thing is DxO's tests are very, very, very stringent. So if even if you have that question paper, right, even if your camera is calibrated using the DxO mark test, you can be assured that at least the camera is going to perform at a certain high quality of performance. So it's not like they're not buying fake scores, they're not cheating. That it's not that. It's just that DxO says, this is a very high standard of quality test method. Use it to calibrate your systems, and then give it to us for testing. So, that's kind of how it works. It is reliable, yes. So to answer your question, I've been wanting to share that information with people for a long time. Why there is not kind of aperture in phones which can work f1.8 to f2.2? Ashu, I actually addressed this in a earlier this thing. It's very difficult. Changing the aperture means you'll have to build a very fine curtain inside your camera lens, and the more moving parts you have inside a camera lens in a smartphone, the easier they are to break. Now you don't want, you've paid good money, doesn't matter how much you've paid, but it's always hard earned, and turns out the aperture broke, while just in regular use. So this is something that, it's not something that can never be achieved. Right now it's only been done by Samsung, and that too it's a very simple implementation. It's not a true implementation of a dual aperture system or a multi aperture system, I would say. So I would say don't worry about it for now. Tech for tubers. What lens is ideal for Canon camera? Well, we're talking smartphones here today, buddy. But since you want to know about ideal lens for Canon in low light, take something with a big aperture, f1.4. At least. So it could be 24, 35, 50 mm, but f1.4 for sure. Arpit, these days smartphone brands are providing 48, 64, 108 MP sensors, but what is the real MP of those cameras? Is there any way to tell the real megapixel? So these are actually really 48, 64 and 108 MP sensors. You can if you can go to the sensor manufacturer's website and see the detailed white paper on them. So the sensor resolution is actually what they advertise, but are you getting the same quality as what you could expect from a 48 megapixel DSLR? No. These sensors have been basically designed to have a very high megapixel count, keeping binning in mind. When you bin the result, or basically 4 pixels into one, you're able to boost the image to noise signal ratio, you're able to boost the amount of color information captured, and therefore produce a better 16 megapixel image, for example, than you would if you had a native 16 megapixel sensor. So there are these things, but there are trade-offs. Like for example, when you go high, like 108 megapixel, you start seeing something called color interference, which is difficult to counter. So there is a limit to how far you can push these high megapixel sensors for binning. Okay, let's see. Gaurav Maurya, in the new iPad Pro, rumored Apple introduced a new LiDAR sensor. What does it do in aiding the camera? So LiDAR is basically used for augmented reality. It's basically there to help you assess the distance between objects and therefore place AR objects in the real world. So it's purely for AR. It's got nothing to do with image quality. It's not like you can use it to take a photo or something. So there is that. Okay, any other questions, guys? I mean, Tech for Tubers has something to ask. I'm also gonna scroll back up and see if I missed anything. Okay. Uh, okay. Now, in terms of these charts, where you can get them. Now, these are all paid charts, and the reason they're paid is because the company that sort of sells them is printing them on very specialized types of paper using specialized types of inks, to prevent reflections, to prevent any kind of fading, things like that. But they do have a software which allows you to generate these charts for yourself. You can print them out, but do note that these charts, once they start fading, will not be usable, so you'll have to sort of keep getting them printed higher. I'll get them printed in as high quality as possible. You can get them from imatest, imatest.com, and they have a software called imatest master. Once you shoot these images, you can feed that into the imatest software, and then it gives you the assessment for all of the parameters that we talked about. Okay. You Rush Premium, do you think a 12 megapixel sensor can still be relevant in 2020 with a bigger sensor? Dude, if you put a 12 megapixel resolution on, let's say, a half inch sensor, you're looking at killer performance. Like, natively, what micro lenses are able to pick up. So, the micro lens is what's on your camera sensor. Each pixel that we call is a micro lens. The bigger they are, that is the pixel pitch, always better, right? As minimal of software manipulation involved, it's always better. So a 12 megapixel half inch sensor has the potential to be better than the 48 megapixel half inch sensor that produces a 12 megapixel image binned. So it's there. And case in point being the iPhone 11 and the 11 Pro, like, they're all 12 megapixel sensors, right? And they are producing some of the best images today, like, hands down, in terms of both quality of dynamic range, color, sharpness, detail retention. It's pretty amazing. In fact, the photo of my dog that if you guys just saw, let me pull that up. This sample over here, this has been shot on an iPhone 11 Pro, and look at that level of detail. So it's definitely possible that a 12 megapixel sensor is still relevant. I mean, honestly, why do we even want more resolution? None of us are printing photos in poster size anymore, so what's the need for that higher resolution? Yes, if you want to zoom in, if you want to be able to zoom and crop out certain parts, yes, resolution matters. But we're still far away from that where we can have best of both the worlds. Okay. Tech for tubers. Contrast whether one has different color. So as a responsible smartphone camera review, on which points we need to stick. Okay. I don't get what you mean by contrast whether other one has different colors, but as a responsible smartphone reviewer, see, measuring the amount of contrast in an image, you will need a software to do that and a calibrated chart. There is no way to sort of eyeball that and say this is how much contrast there is in the image. But you can look at everything else. You can look at sharpness, you can look at center sharpness and the corner sharpness. Those are two distinct parameters. You can look at dynamic range, you can look at detail retention, like I showed you. So if you're shooting the right kind of things, for example, shooting a flat wall for detail retention makes no sense unless the wall has a lot of texture, right? So you have to make sure that the subject you're shooting is representative of what you're trying to test. So stick to that. Arpit, Samsung is provided 100x space zoom camera which looks different from normal smartphone camera. Why? Are you talking about the image results or the camera module itself? Once you clarify that, I can give you an answer for both of them. Okay. Nokia once launched a phone with 40 megapixel camera. What do you think should be compared to today's 48 MP sensors? Oh, Ashu, I actually have the Lumia 1020. That's the 38 megapixel. There was a 41, the Nokia PureView 808. Can it be compared? No, because sensor technology has come a significantly long way since then. We've refined the way we sort of build the micro lenses onto the sensor. There's the backside illuminated design that's changed. There has been so many changes in the way software handles the raw data coming out of the sensor, packages it, etc. That being said, The Nokia Lumia 1020 producing its high resolution image is still very, very detail rich. Like, it's still fun to look at. I'm not gonna deny that. It's just that that camera is so slow that by the time you try and take a photo, your subject would have probably moved. The modern day cameras with their 48 and 64 and even 108 MP sensors don't have that problem. They're very quick. So there is that. Okay, one sec. Aha, I missed tech for tubers. I missed the first part of your question. So he says, different brands have their own camera application. Same sensor is optimized in different ways in different smartphones. For example, one with same sensor have different color reproduction and different contrasts. Whether one has different colors. So responsible smartphone reviewer, on which points we need to stick. Again, same thing. We've actually seen a lot of 48 megapixel sensors, smartphones with 48 megapixel sensors. They're the same, let's say Sony IMX 586 sensor, same lens, same everything, but you see a different output from all of them. Your parameter for assessment will remain the same. You are still looking at the same quality of the output. You're looking for dynamic range, you're looking for color, contrast, sharpness. You're still looking for all of that. And you're right, a lot of them have implemented it differently, and that's everybody's choice. So a lot of companies will focus, for example, on giving you more vibrant colors, like a very high amount of saturation. Maybe that's not that great, and from our testing, it's actually not a very good thing to have a very high amount of saturation, because when you have colors becoming too saturated, they sort of change. Like when you add more color to a particular shade of green, the hue changes, so it may no longer look green. It may become dark green, or it may become something else. So you have to still assess based on what kind of dynamic range you're getting. Is the image sharp in the center and the four corners? And then of course take that into low light, and then make the same testing process be repeated, and see where each of these stands. And believe me, you will find differences. We find differences in practically every smartphone camera, so don't worry about that. Okay. Rakesh Rao, how does the astrophotography mode work in GCam 7.3? Personally, I have no experience on that, but if you look at how the Pixel 4 is doing it, is basically doing some very interesting things. It's combining multiple long exposures with what are called black frames. So a black frame is essentially, if you're shooting something like a 5-second exposure, you take another 5-second exposure, but you black out everything, and then only thing you have left is the noise generated by the sensor. So when you do astrophotographhy, astrophotographers will always do this. They'll take a photo, let's say for 30 seconds, then cover the lens, take another exposure for 30 seconds. Now you have a black frame which is giving you the noise pattern, and then they combine the two to remove noise. So that's sort of how it works. A lot of long exposures and a lot of calculations basically. Rush Premium, sir, can you explain if there really is an advantage of RYYB instead of RGB like Huawei is doing recently? 100%. If I don't know how many of you are science or physics nerds, but the color yellow is a combination of green and red, right? So an RGB sensor has one green pixel, one red. Actually, it has, for every red and blue pixel, it has two green pixels. So one red, one blue, two green. That's how it works. By replacing the green with yellow, they've effectively increased the color information being recorded in that one particular pixel by 40%. So you've got red kabhi information, you've got green kabhi information. Combined, it becomes yellow. So with the same pixel layout, with the same aperture, they're able to capture more information, which is how the P30 Pro, for example, was able to take these really insane low light photos without even switching over to night mode. And honestly, it's impressive. So yes, there is reason to be excited about RYYB, and RYYB implementing on telephoto is even more exciting. So hopefully looking forward to the P40 Pro for that. Okay. Imam Madi, while capturing a photo, should there be some important points to click an image rather than just brightness, saturation, etc. So Imam, whenever you're taking a photo, you always have to make sure that it's a good exposure. If your photo is underexposed or overexposed, you've already pushed the sensor beyond its normal operating capabilities, so it's not a fair way to assess. So you have to make sure that your exposure is at least correct. Then depending on what you've pointed out, yes, are visual characteristics, brightness, contrast, color, but you also have other parameters like sharpness, you have detail retention, and you have distortions. These are three other things that you have to look for. We've discussed that in the presentation, so you can go through that again if you would like. If you have more questions, always feel free to add them to the comments. Why don't companies provide exact same megapixel in sensor as well as lens like 40 MP OnePlus 8? I don't know why the OnePlus 8 reference, Ashu, but here's the thing. So the resolving power of a lens is not something that's ever been talked about. Like, even in the early days of DSLR cameras, when the DSLRs moved from being 8, 10, 16 megapixel shooters to then 24, and then Nikon shocked the world with like a 36 megapixel DSLR, that is when people finally started talking about the resolving power of a lens. See, I'm wearing glasses, right? These glasses have a power, that's a resolving power. They're doing correction to the light coming in so that my eye is able to see that light properly, which is what lenses do for a smartphone or a camera sensor. They have to be able to resolve, and it's like this. Imagine your car tank, right? If you only put 2 liters of petrol in your car tank or in your bike, you can only go so far, but if you fill it up, you go farther. So it's sort of like that. If the lens and the sensor match in terms of their resolving powers, the lens can always have a higher resolution than the sensor. That's not a bad thing ever, okay, but it should not be lower. And honestly, without really taking the sensor and the camera assemblies apart, it's really not possible to test the resolution of the lens per se, because if with a DSLR you can mount it on a specialized testing bench and then test the DSLR lens ka resolving power, but you can't do that for a smartphone because you'd end up breaking the assembly. Okay, tech for tubers, I'm glad I could help. Then okay, Arpit, you want an explanation on both points as to Samsung is providing 100x space zoom camera. It looks different from other smartphone cameras. Why? Okay, one, they're using what is called a telescopic or a periscope design lens. What that basically does is, in order to have a telephoto lens, right, the more telephoto a lens, the bigger it's going to be. You need a lot more lenses with lens elements in order to see farther away, right? Now, you can't do that with a smartphone without making it much thicker. So, like, you wouldn't want a smartphone that is like 5 inches thick, right? You wouldn't want that. Nobody wants that. We all want it to be as slim as possible. So, what lens makers figured out was that what they could do was use prisms. So, light goes in and hits you. So let's say if this is your camera sensor and there is a lens here, light goes in and hits the camera sensor. This is how a normal assembly works. What they did with the Samsung 100x zoom camera is they basically used a prism. So light goes in, hits the prism, and then moves sideways. So the lens is mounted actually like sideways on the inside, which is why that camera module looks a little different. Now, in terms of the image looking different, well, there is also a lot of digital enhancements happening, and there's a lot of processing going on. It's not a true 100 mm or a 100x lens actually. It's and that is why you have the images coming out look different. So there is that. Okay. Rush Premium, sir, is high frame rate slow-mo mostly done using frame interpolation? Do we have any real slow-mo for say 480p and 960p? Don't hate me when I say this, but Sony smartphones can do true 960 FPS slow-mo. Okay, what you're talking about is actually a factor of the image sensor. What you can do is you can go to, let's say if you want to know if the IMX 586 for example is capable of true 960 FPS. So Google IMX 586, go to the manufacturer's website and there will be specifications there. Now sorry, you want to find if the sensor has a DRAM layer within it. If there is a DRAM layer inside the sensor, that means it can do true 480 or 960 FPS. Because think of it this way: a 720p frame, right, which is 1280 by 720, you need 900 of them or 1000 of them actually for 960 FPS. 1000 of those frames per second. Even if each frame is 1 MB, you've only got 1 gigabyte of data, right? So, and our smartphone processors, the sensor, ISP, all of that cannot process data that fast, which is why Sony basically cleverly designed this sandwich sensor, where you have the sensor layer and then right underneath that you have a DRAM layer. So that DRAM is able to store all of these frames so that your ISP buffer gets cleared, and everything is recorded properly. So look for that. Look for if it's it's called a stacked CMOS sensor is what it's called. Look for that, and it's a specification, so not all Sony sensors are stacked. There will be some specifically labeled as stacked CMOS sensor. Okay, Imam Madi, compared to Xiaomi mobiles and Oppo and Vivo mobiles that to a camera phone, compare both while clicking image. There is some different looking image. Okay. Alright, Imam, so we covered this as well. If you have, let's say you have three phones, right? One from Xiaomi, one from Oppo, one from Vivo. They have the same 23mm lens. They have the same 48 megapixel sensor as well. Let's say, assuming, right? You may take a photo and on the phone you see, oh, all three look different. Now, that can also be a factor of the display. Okay, all smartphone displays are tuned differently, unfortunately, which is why in our presentation we say that when you're reviewing a smartphone camera, you need to look at all of the images on a computer display, like everything then becomes equal. Once you take them onto a computer display, you'll be actually be able to assess whether the colors being produced are, which one of them is more accurate, which is off, where you have white balance issues, things like that. So that's basically how you look at it. Okay, Arpit, so that 100x space zoom camera can adjust its focal length. It can't adjust its focal length. It's a fixed lens. What it's doing is basically, so you're not getting a 108 MP output, right? You're still getting a 8 or a 12 megapixel image output, and it's using the rest of the resolution to basically zoom in. So that's how they're doing it. It's not really a true zoom lens, but they do a good job on the 100x space zoom lens. Of course, on the S20 Ultra, that's how they've done it, where you actually have a telephoto lens. So there is also that. All right, so on that note, guys, I'm gonna end today's session, and I hope this has been helpful for all of you. How to test camera sensors, and it's very simple, right? Look for these image parameters. If you guys want to take a screenshot, I'm going to leave the screen up here. This is what you need to test for. You can use a combination of charts and real world samples. I would recommend having both, because it helps you make, just because something performs really well in a test lab doesn't mean it'll be very good in the outdoor world as well, which is why we do both level of testing, which is also sometimes why you see a camera that does very highly on a DxO Mark lab test may not do so well in the real world, or vice versa. It happens. So just make sure that you are looking at these parameters when you're testing your smartphone camera, and If you have any questions, you can always email us, you can write into us, you have our contact details, and we'd be happy to take them up. If there are any further questions, I'm more than happy to answer them over email. So thank you guys for watching, and all the best. You have 1 week now to submit your review based on the benchmarking session and the camera testing session today. I do understand that the smartphone benchmarking session was cut abruptly last time, so there will be the Q&A will happen tomorrow. Stay tuned for that. So the updates will come to all of you via the app as to when that exactly will happen, but it is tomorrow. The time will come to you later. And thank you guys for tuning in, and have a fun time testing your smartphone cameras.